How do we condense these three different logs here? So first thing that you're going to see is that the 7 can be written as x to the 7, right? So you're undoing the power rule. You're going backwards using the power rule, right? So you're going to have log base 3x input raised to the 7th power, right? You're going backwards with the power rule, right? Basically, you knew that if you were given this, the answer would be that, right? The simplified version. But here you're undoing it, you're going back. So you're putting the 7 as the power of x, right? So the same thing is going to be here. Plus 3, I'm sorry, we're getting rid of the 3, plus log base 3. Now 2x will receive the power of 3, right? Because the 3 goes back on the top. But be careful, the 3 doesn't apply just to the x, it applies to the entire product of 2 and x, right? 2x, right? So the 3 applies to both. That's why you have to use the parentheses. Okay? Minus log 3 2x to the 8th. So luckily the last term we didn't have to, do anything there. So now what are we going to have? What is going to happen? Notice that there is a sum of the logs with the same base. So that means we can combine this into a single log with the same base and simply have these two inputs being multiplied. So x to the 7th will be multiplied to this input. But be careful, this input is raised to the 3rd power, right? So that's going to be 2 to the 3rd times x to the 3rd, right? And we're done. So minus log 3 2x to the 8th. Let's not touch it yet. Let's not touch this yet. So now we have to simplify this part, right? So it's going to be log 3. So the x's are the bases that are the same. So that means we can simply keep one base and instead have the resulting power being the sum of 7 and 3, right? So using the exponent summation rule, right? So it's going to be 7 plus 3, which is going to be equal to 10, right? So we might as well just erase it like that and write it as x to 10. But here's the thing, let's write 2 to the 3rd first, because that looks better, right? 2 to the 3rd is 8, so 8x to the 10. Beautiful. Minus log base 3 input 2x to the 8. So now here's the thing, before we knew that there was a sum, so we knew that we have to deal with the product of the inputs, of the separate inputs here, but now we have the minus sign, right? We have the minus sign and we have the same base, so that means we can simply use the quotient, right? As you can probably tell, since there's a minus, we're talking about the quotient of the inputs of one single log with the same base 3, right? So it's going to be log same base 3 and the quotient of these two inputs. And what goes on the top? Of course this, right? According to the order, this comes first and then whatever is minus, that comes in the bottom. So basically what we're going to have is 8x to the 10 being on the top, the first input, and then this input will be on the bottom, 2x to the 8th power, like that, right? And now we can simplify the inputs, right? So it's going to be log base 3 with the input. So what's 8 over 2? That's 4, right? And actually we don't have a fraction as a result. So using the exponent rule once again, before we had the addition, right, as a result of the base being the basis x being the same, so we added the respective powers, but here we're going to subtract respective powers when the bases are the same using the exponent rule, right, the division rule. So it's going to be x to the power of 10 minus 8, right? 10 minus 8 is 2, right? So x squared is your result. So the answer is log base 3. The input is 4x squared, and don't try to expand it back again to to have two separate logs for individual inputs, 4 and x squared, right? Because in this problem we need to actually condense, right? Condense meaning to make it into a single term, right? Single expression or single term. In this case there's one single term, so this is sufficient. You don't have to do anything with this. Thanks so much for watching. Hope this was fun. See you in the next video.